Okay, so the I'm gonna put a tab over here. Nice. So I don't know if there's a homepage for this book. I can't actually find it, but I ordered it directly from Amazon. See if there's anything else. Amazon, Goodreads. Okay, so I think you basically just want to get this link if you want this book. But the reason we are working on this book is basically because we don't feel super confident about working with monads still. So I think that I have a decent understanding of what, why monads exist, or like what is the pattern that makes a monad a monad. However, I don't have any experience using them, and working with them in reality. So that's what we're hoping that this book is going to do for us. Feel free to ask me any questions. Oh, I need to update probably the book command, but that's okay. So we're doing this book today. I was planning on doing one interesting thing about this book, which I wasn't expecting and I didn't actually know, is that there's a good amount of Scala code in this book. So we might have to I think there's one example where you actually are asked to write Scala code in this first chapter. So we are going to potentially be writing some Scala. I don't know if I have that installed. I do not, so we'll have to figure that out. But there's a lot of comparisons between Haskell and Scala. SDK Man IO. I've never heard of that before. What is that? Let's go. I apparently deleted this. Nice way to keep. Oh well, we're not planning on doing a lot of Scala code, so I'm not too concerned about that. We'll probably just apt install it or something, just to get it. I think I only have to write like a tiny bit. So, but I don't really write Scala ever. I think I wrote it once. We worked through the other functional programming book, but yeah, we didn't get very far. Okay, so let's start and we'll see where we get. Oh, so one thing we were supposed to a while back go over the continuation monad, but I've decided to wait on that because I think we're going to talk about it in here. So it says the choice of topics is guided by pragmatic considerations, in particular what works and is used by the community, with an occasional detour into theory. Other programming concepts such as functors, applicatives, and continuations are introduced wherever their relation to monads is interesting or leads to further insight. So I think that that's really important. We will, we'll get to continuations in this book, so we might as well just let Alejandro explain them to us. Okay. Book is broken up into 5 sections. That's probably not that important. The code formatting, you'll see, I don't know, if you haven't seen this book, it's absolutely beautiful. The typesetting is really, really nice. So it's, yeah, I would suggest that. So let's go see if we can get Scala real quick, because I don't know how to do that. Scala SBT. Oops, sorry. Hopefully that wasn't too loud. SBT is the tool, right? Should just be in the repos. Yeah, I mean we could just try and no SBT, but maybe it's no. Maybe if we just install this, we get it. I guess we're gonna find out. Let's just do that. Wait, why is this? Oh, it says no longer required. I see what's going on here. Yeah, we gotta install a Java, of course. No, you don't get that for free. Okay. I mean, we probably don't need to keep this updated, but like, oh yeah, I I got you beat by it. The shortest, tiniest second. um, yeah, I mean, this is probably fine. I don't think that this is going to be a problem. Don't think anything will get printed that I need to worry about. Oh, that's the same key, so we're fine. Okay. Update. Okay, cool. So, I think it's like a similar setup where you're like SBT new and then something. Oh god. Oh no. Is this font okay? Give it a little bit more. Okay, let's keep reading while this is doing its thing. There you go. Okay, it's doing its thing. So the first thing it talks about is type classes. So we do a ton of review in this chapter. So anyone that's like been around here for a little while and sort of knows what's going. Uh-oh. Okay, there we go. It's just not. It's just not dash help. It's it's one of these classic things. Yeah, that's fine. It's just I don't know how to use this, so um, there's no way to create one of these directories. SBT create, I guess. We'll get there, I suppose. I don't know what's going on. We're on this one. Okay, so we just need to create this thing. And then compile. Is there no way to make like a little project? This is not what I want. Oh, thank you. Sorry, I didn't see that. New Scala seed G8 is the basic. Perfect. Okay, so that's what we're gonna do. We're gonna do sbt new Scala seed dot G8. Yeah, and that G8 thing is like some sort of like template-y file, right? But does that make this current directory the template project? I guess it has to, right? That's not what I wanted to do, but that's okay. Should be a new deer. Okay, let's try this. I don't know. I probably can't call it Scala, huh? Sourcing from GitHub. Right. I do sort of remember this. It takes forever to get the Twitch thing to trigger in Discord. Let's just call this chapter 0 Scala. I don't know. Sure. So SBT. Well, I guess what we'll do is we'll do it this way, but put this over here, and then we can just compile in one main. Oh, I can just write SBT run. I see. Okay, so I don't really need this. That's fine. That's fine. We'll just work on it this way. Okay. It seems like a lot of boilerplate for Hello World. Okay, so then we just write SBT run. It doesn't explain any of this either, so I'm sort of just kind of working from essentially what JS Grant is telling me. So thank you, JS Grant, because I really don't know what I'm doing. Okay, here's the output. Fine, good enough. Okay, so we'll keep going. I mean, we're just like hacking, so it, you know, I'm not really trying to become a Scala person, but there is some code in here that we could discuss that's Scala related. I don't know. We are typically a Haskell stream, so fine. Okay, so we'll go back and forth as necessary, I guess, but oops. Hang on. So yeah, so we got to use a slightly older version of Haskell, of this. What is it? Of Stack? No, it's Haskell, the Haskell resolver. Because the LTS 1329, I don't have the HIE compiled for it. So now I think we should be able to get auto completions, but we'll see how that works. Okay, so type classes. If you're unfamiliar with them, look something, there they are. Look something like this. Okay, so we're defining a constraint class here, or a type class that determines how to say whether or not A's are equal. So in Haskell, this is what the to use the operator equal equal, you need to define an instance of this type class. So if you had, for example, all you need to do is define all of the cases where, you know, you want this thing to be true or false. So false. Okay, so for, why is this complaining? Oh, right. Let's put a prime here. Yep, see ya. Sorry, it's bedtime. My apologies. Glad you stopped by for a little bit though. You got us up going for sure. Take it easy. So essentially every single type that you want to use this eq type class for, you need to define instance for eq. So in this case, we can do bool. You can do lists. So for example, you could write instance eq a so we're going to define this recursively, so we can say and then I guess, yeah, anything else is false. Oh. So you can use, what's this complaining about? No, this is not right. There we go. Oh, well, this is going to be problematic. Thank you, NewMade. I just missed that. We're going to have to call this something else. So, I don't know. Can we put a star here? No, it's about the operator itself. Because we're trying to overwrite things from the preload. I suppose we could do import prelude hiding eq, something like this. Yeah. How's it going, NewMade? So let's see if this works. Give me a second. I've not played with hiding very much. Oh, I didn't realize that that Swarm streamed at the same time. Or are you just watching something from previous? Oh, wonderful. Okay. I should check out Swarm stream. I haven't done that before. Okay. And I should mention that we're doing something pretty lightweight today because yeah, we're gonna do right a little bit in this in here. So yeah, I don't know. So here's actually the first exercise. So we're playing softball today because mentally I can't handle playing anything harder than this. So we're gonna work through the beginnings of this book, and that's all I can handle today. Um, y prime. New maid, cheering some bits. Nice that you are streaming. Thank you very much. I'm happy I'm streaming too. It was hard to keep my mind off of the crap that happened this weekend, so I'm hoping that this will help me escape from that. The good news is nothing was actually stolen, so that's convenient. And now I just have a safer house. I went and bought a like a security system, so they're pretty easy to install as well. Okay, so that's what this looks like in Haskell. Pretty easy. We've done code like this a bunch, so not terribly hard. Now we're gonna try and write the same thing in Scala, which is gonna be a lot more interesting, I suppose. So I think that we edit this. Excuse me. And we don't really need to change this at all. We just need to write some code and check that it compiles. So in Haskell, or in Scala, you write something like this. I already hate it. Def eq x y. Okay, so yeah, it's just like after writing Haskell, it's so verbose. Like I couldn't imagine somebody being like, "Oh, go write some Java code." Let me put these side by side. All right, so these two definitions, the trait and the class, are essentially the equivalent functions in Scala, and Scala on the left, and Haskell on the right. It's not that verbose, honestly. It's just so it's so different that I don't like it anymore. Okay, so that's that. Now we want to write this eq list function, which is gonna make you want to throw up. Okay, well, this isn't so bad. Wait, no, but that's the Boolean one. How do we... It doesn't show the definition of this. So I guess we have to figure out how to write it. We'll try and write it, I don't know. Yeah, it's just so much. It feels like so much work in every other language now. Um, so we're gonna take. Oh, is this supposed to stick here? I don't know what the style guide says. Here, let me. I have no idea what I'm doing, by the way. I'm just gonna try this. We'll just put this like this. Okay, so it. How do we represent an empty list? Like this, maybe? Oh, and there's a case. My gosh, there's so much syntax. I don't know how to do this. Why am I trying to do this? Um Nil. Okay. That explains that, so nil, nil, true. Can we match anything? Is this even the right booleans? Yes. Okay, so we gotta do this one. Case N. The hell does rest mean? Oh, okay. Rest. This is the syntax for getting the head off. Okay. Yeah, yeah. It wasn't obvious to me. I've only ever seen that syntax in Haskell. Uh, so I guess I do it in here. So we're gonna say like x. Eh? I don't know. SBT compile. Expected start of definition. Oh, maybe this is supposed to be def. What's up, Bredor? How's it going? We're painfully trying to understand how to write this. Well, okay. Let's write it this way. Yeah, probably on Tuesday, I guess. I might do this book on Tuesday and that book on Thursday or something. Sorry, I can't do anything mentally taxing today. I just won't be able to handle it. God, there's so much syntax. Do I? No, it's the equal sign. So then I just tuple these up. Yeah, good question. Because in Book of Monad, there's some Scala. So I'm gonna try and write it. Even if it hurts my brain right now. I don't mind taxing myself a little bit. Maybe this is right. I don't know. Let's try it. Yeah, so welcome to the new Scala stream, by the way. You know, we're gonna be writing Scala from now on. Obviously, I'm joking. I have no idea how to do this. Maybe this has to go. Okay, let's try this. Hang on. I have one more idea and then I'm done. Because this makes no sense to me. So, implicit val equalist colon. So this thing, and then you write is that right? Implicit val equalist eq a list a list a did I not have it might be like that. So the only problem with that is that then the EQ is required. I think you have to write that EQ thing as parentheses after the fact. The problem here is I don't know I don't know where I'm supposed to put this. I thought that I could just put this outside of my object, but I don't know that I can. My hello object. So let's try this real quick and see if we get this to work. Yeah, that's from the book, but that's the wrong way to do it. It says Luckily, the Scala compiler provides implicits to solve that exact problem. No, that's okay. No, that's fine. No worries. I see what you're trying to help me. I appreciate that because I don't actually care about this. I'm just trying it because it's here. Ooh. Well, we got further that time. Not found. Oh, I probably need the A here. Maybe. I have no idea what I'm doing. If this doesn't work, we'll write it the other way. Doesn't work. I don't know what I'm doing. That's the problem. Okay, let's go back to the other way. Hang on. Def equals A XS YS implicit returns Boolean, and that equals. Could we put this on another line? That would look a lot nicer, wouldn't it? Like this. Yeah, there's an implicit def. Oh, I didn't see that one. Wait, how's that work? Implicit def. Well, that's pretty interesting. Yeah, this is weird. I don't know. Let's try this one. There's less errors. Not found. Value true. I wish the definition was here. This would be a lot easier. Does that just lead to this one error left? Example.eq does not take parameters. What the hell does that mean? I don't understand what this means. Yeah, but I'm not trying to do eq list, right? Eq list is for a list. I'm trying to do eq for two A's. But I guess that's not defined, is it? So I just need to do like, I don't know. Let's cheat. Yeah, let's just cheat. They could probably do this. I assume that you can just compare A's in theory. Yeah, okay. Fine. We're going to cheat. Yeah, it's just we write Haskell so much. Yeah, I think I'm not particularly interested in learning this right now. But I did want to kind of try and write something, because it does ask you to do a Scala example. So yeah, like here's an exercise that's written for Scala. So how do you do comments in here? I think it's like C. So I like to do all the exercises if I can, essentially. So define not equal so I also suppose we need to define oh my god, this is terrible. It's really not that bad. It's just very different than what we're usually writing. So where are these truths coming from? Oh, whoops. Okay. So I think you do this. Oh, apparently you can just do, you don't need to do this, you can just write that, which makes sense. Okay, so then we can write something. I guess this, and then implicit eq. We probably don't even need to do this. There's probably a not function, so you probably can just write like not eq xy, assuming there's a not function. I don't even know how to write this code anymore. We'll put it in parentheses. Well, I suppose this is kind of not really the way they want us to write this, because we're just like replacing this, but maybe that's right. I don't know. Let's see if it compiles. Do we need parentheses here, or can we do single line functions? I really don't know. This is hard for me to read. He shoots. He's wrong. I'm done with this. I'm over this already. Yeah. Yeah, I'm over this. This doesn't make any sense to me. We're ignoring the Scala code. Sorry, Scala. I'm not in the mood to learn you as well. We're trying to learn about monads, not about Scala. We're skipping this. Sorry. If you were really coming here to see a Scala stream, then you weren't paying attention to my title. Well, I guess that's not true. Do I write Haskell in the title, right? Yes. Okay. We're done with that. The other thing that we could probably do is move. Yeah, like, I'm not trying to learn that. If I was interested in learning that, I would have picked up the book. What did I break? Something's broken. Oops. Does this thing, oops, does the lock file contain something about the path? Doesn't look like it. Build. Seems fine. Not this. Okay, cool. Skipping that. So, that was basically just supposed to be about type classes and yeah, yeah. He writes in a lot of languages, so yeah. So this is just to re-explain type classes and instances. So we know how to do this in Haskell, so we're gonna stick with Haskell. We are going to skip the Scala stuff for now. Okay, so I think the reason that, and I think it's said in here, the reason that they're using Haskell and Scala is that they have higher kinded abstractions. So you can write higher kinded types such as oops. I assume it's like this. Yeah. So you can write things like this where you're saying I'm going to instantiate a type class of a container that contains two functions, empty and insert. You can do this again in Scala, but we're going to ignore that. Yep. Okay, so it says write the list instance or implicit value for the container type class. So we're going to skip, that's a Scala question, so we're going to skip that and write this for lists. So instance, although how do I, Oh, I don't need plus plus here. I can just use colon because, and actually we can just literally write that. Okay, so to instantiate the container type class for list, you can just write the following. So again, the empty is just the empty list, and insert is just going to take x and the rest of the list and just put the x in front of the xs. That's all we're going to do, which is exactly what they show here. But you could also put things at the end of the list. So would be like list before, but we could wrap things in a new type and say like new type q a. Let's I suppose we don't need to do this on multiple lines. And then we could write instance container q so a type, if you just write, I'll just show an example. You write type, yeah, well, you may beat me to it, but that's okay. If you write like age equals int, this is just a hint to the compiler that every time you write age, you mean int. But a new type takes a parameter. A type, I don't think, can take a parameter, right? You can't write like age a. So to the compiler, these look exactly the same, right? Because this list a is represented as a list anytime you see a q, and anytime you see an age, it's just represented as an int. But this can't take arguments, and this can take exactly one argument. Oh, they can? Interesting. So data creates an actual new type. So when you do anything with data, it's creating a new type to use it. It has to be fully applied when using it. Interesting. I'm not sure I've used. We don't use type very often. We tend to use either data or new type, unless we're just defining some sort of simple alias like this. I don't think I've ever used a type that takes an argument. Have we? Maybe. Hard to say. All right, so this one's gonna be think like this. Yeah, the differences are a little subtle, and but they are important. When you can use a new type or a regular or type, it's better than data because Haskell can do a lot more from the type system standpoint. The compilations are simpler. Like those types only exist in your code. They're compiled away. Um, do. Yep. Okay. So anyway, we did this. So that's what it's like. You can also write this, which is obviously equivalent. I'm just want to write it down just so we see it. You can write unq. And these are exactly the same definitions, so it just depends on what you like. Excuse me. I tend to prefer writing it this way, personally, but I don't think that it matters that much. Okay, let's see if I missed anything important here. We talk about, man, like, I can tell I'm already tired. I'm glad we're doing very light stuff. They talk a little bit about GHC in here and how you enable language extensions in GHC, but we know how to do that as well. So we're basically ready to keep going. So that was actually chapter 0. That's it. Basically, type classes, instances, new types. Wonderful. Oh, and we were doing this last time, so let's start doing this again. I actually like this idea. Putting the chapter title in the README. Not that this one's particularly interesting, but introduction. We got to change our resolver to the one that works, and we need to fix this code. We should probably make our own stack template. I think one can do that. Like, you can do it for SBT. I think you can do it for this as well. Okay, so we're gonna read this one a little more closely because I think we're gonna attempt to discover monads again, which, you know, is the title of the chapter. So that's important. Yeah, do we know how to do it? Like, is there documentation somewhere about how to do this? What if we just did this real quick? Do I already have one of these open? I do. Let me get rid of this. Go away. Stack. Template. How do I, like, tell it where these things are, though? Can I give it like a list? Okay. Which is here? Yeah, look at that. All right, so I can probably copy this one. What's his etag file? Does this, do you know what this means? I don't know what that means, but that's probably fine. So what do we want to call this? Chapter? Yeah. Okay, so we need to go find 13 point. Oh, okay. I don't really care about this. That's fine. I'll keep the main file there just in case we want it later. But what we do need to change is our package YAML. I guess we don't. So we're gonna write stack new this thing, and then is there a way to set my resolver? Resolve. I'd like to set my resolver. I suppose I can just do this when I do it. Yeah. That's fine. Let's just do it this way. This is probably fine. Okay, so anyway, let's go test it. Programming. Haskell. Book of Monads. Okay, good enough. Wonderful. Okay, that's a little better. It'll save us a little bit of typing. I probably would like to just set the resolver to 1327 until we update HIE. But anyway, I think that's fine. So we're gonna find a tree. Okay, so let's go here. Monad is an abstract concept, which we programmers discovered after many attempts to refactor and generalize code. One way to introduce monads is to state the definition and derive information from it, mathematical deductive style, which is what we did when we went through Haskell programming from first principles. Oh, you know what I just noticed? Since NewMade gave us those bits, he is overtaking Active Fireball for the top cheer of the month. I think it's the month. So good for you, NewMade. Anyway, in this chapter, however, we'll try to arrive at the concept of a monad by means of a series of examples. In order to help you cultivate an intuition for it, words such as context or box are used throughout the chapter. Feel free to ignore those parts that do not make sense to you in order to come to your own understanding of what a monad is. Okay, cool. So, oh, yeah, so this is called an ADT as well, which is something wait, I thought ADT was supposed to be abstract, so maybe this is not supposed to be an ADT. This is an algebraic data type. Okay, whatever. I still don't understand what an ADT is. I think it's an abstract data type, but I don't know what that means in Haskell right now. We can ignore this because this is just syntax stuff that we all know how to do. We can write a function that counts the leaves, so we'll do that. Number of leaves, which is going to take a tree A and return an integer. Nope. Integer. What? Okay. So number of leaves. I think it's something like this. Yep. Okay, so basically we just recurse through the left and right subtrees until we find the leaves, and then we just add them together. So function works in a recursive fashion. Pattern matching. We know what pattern matching is. We're pretty familiar with Haskell at this point, so that's great. Things get a bit hairier for our second example. Relabeling the leaves of the tree left to right. If you start with a tree T, the result of relabel should contain these same elements, but with each one paired with the index it would receive if the leaves of T were flattened into a list starting with the leftmost leaf and ending with the rightmost one. Okay. We can spend a long time trying to implement this function in a simple recursive fashion, as we did for number of leaves, only to fail. This suggests that we must hold on to some extra information throughout the procedure. Will we fail? Can we use a go function? I guess not, because we have to go. We can't write this in a recursive fashion? Really? I guess we have to try it, right? Oh yeah, I guess I can already see an issue. But we're gonna need to have a go function, which is gonna take a starting number. Do we start at 0 or 1? It says 1, so we'll start at 1. Let's start at 0. So I think we have to recurse to the left one first, and then the right one. I don't know if this is going to work right, but I'm kind of curious because I thought that one would be able to write this recursive function. Maybe somebody can tell me I'm wrong before I get going, but it seems like it should be possible. Swarm Collective hosted with 8 chatters. Hello. How was your stream, Swarm? I think someone was mentioned they were watching you a bit earlier. I wasn't sure if you were streaming right now or they were just watching something else. I don't know that they responded to that. How was your stream? What were you working on? We're trying to write a recursive relabeling function on a tree. It might... My gosh, my phone is exploding. It says in this book that in theory I shouldn't be able to do this, but it seems like if I use a go function and recurse to the left subtree and then followed by the right one, I should be okay. What is that arrow for? Oh, you said it. I see. Gotcha. Oh wait, we're hosted. Hosted is different than rated, right? What's the difference? I don't know. Either way, thank you for the host. Where was I? Okay, so now we're gonna have a... Yeah, I guess how do we solve this one right here? Yeah, I don't see how we solve this problem. Right? This is where it becomes, I guess, impossible. Oh my gosh, my cat is whining. I need my phone to stop buzzing. I'm going to mute it because this is really distracting. Can we do this? I don't think we can, because how do you get... You have to do something with the result of this. You have to do something with the furthest right value of this, I guess. It's kind of a pain in the butt. Hmm. I don't know how to write this part. You need to find the furthest right tree, I guess? You need a function like this. Wait, why is it? Why am I getting that a second time? I'm very confused. I don't know how this works. How this hosting things works, but either way, hopefully we don't get that every 5 minutes. Okay. We'll survive. Leaf. Well, no, because this... Well, no, this will always recurse down the right subtree, so this should be okay. I think. I'm very curious if we can do this. Should call it N. We've been calling it N. Um... Does this look right? We're losing a ton of viewers. 5 viewers. I think this is right. Because we recurse completely down. The idea is recurse completely down on the left subtree, and then figure out what that index was, and then recurse along the right subtree. I think this logic is correct. Yeah, you're absolutely right. You're absolutely right. I don't need this function. That's a waste of time. You're 100% right. Nice. Good call. Let's do it that way because we don't need this extra function that depends on the internal type that we're using for this relabel. I like that a lot better, actually. Does this look? This seems correct. Let's see if it terminates, I guess. I mean, I'm willing to like blow up my computer for no reason. So, oh well, we need something to test it on, don't we? Um, uh, okay. So this is gonna be our left subtree, right inner subtree for that one. That's our left subtree, and then we're gonna have a right subtree with the same depth. Okay. And then in here, we're gonna have leaf 1, leaf 2, leaf 3. Oops. Okay. And then I keep writing lead. 6 and okay. We'll do that, and then we'll need B equals relabel A, and then of course I think we just want to remove this outer set of parentheses. Okay, there we go. It didn't quite work the way we want. Yeah, I need show as well. Let me just fix these numbers. 7. And actually, we don't even need to define B. We'll do it from the command line. So instance show tree where we need show A, show tree A. Oh, that's true. I think I would like the parentheses at least. right? So then at least we have parentheses for our trees. I think this is right. Is anyone hating this function? This seems close. It might not be exactly correct, but we'll see what happens. Okay, so relabel. Oh, we don't, because we're counting, we don't need to add one. Oh, no, there's an error. 3, 4, 4, 5. Yeah. Driving show will put parentheses where necessary. Oh, okay. So 3, 4, 4, 5 is confusing. Maybe you can't write this. Yeah, well, to be very clear, that's exactly what we're going to be doing here in about 4 seconds. I just wanted to see if I could write the recursive definition, even though he told me that I can't do it because I'm stubborn and I feel like I should be able to do it, but I don't think I can. But this is exactly what we're going to use state for, and this is exactly how they're motivating the use of the monad pattern. Okay, so I don't think we can do it, but let's look just a little bit longer because it seems to me like we should be able to. We do need this, by the way. We do need to add one here. Why? Oh, I see what you're saying. Like, just, or I think I see where you're going. Maybe. I don't know where you're going. We're going to completely rewrite this function, I think. Yeah, okay. There is, but I don't know, how do I store that information? I mean, I don't know that I can store it in the recursive fashion. I think that's the point. Is that you need state to make this work. Turn a tuple. Well, what's the other thing that I store? Return a tuple. Return a tuple where? How many leaves have been traversed? That could work. Maybe. I'm not sure. Oh, I see what you're saying. Maybe. We're basically just embedding state. So wait, but I don't have access to this. Wait, yes I do. Wait, how do I get access to this? N. Yeah, I don't think we want to be doing this. This just proves that we want state. So, also I don't see how this is really going to work. It's going to be, the mechanics are going to be very tricky. So let's just give up on that. Okay. Hey Oren, welcome back. Where'd you go? Hopefully to take a quick nap or something. Oh geez, it's very late already. I thought we were going to get further than this. I'm starting a new book actually, and I think I'm gonna finish on time today. And I apologize for everyone for doing Scala for a little while there. That was weird. But we might come back to this tomorrow. Baby duty, fair enough. Gotta do that. That's very important. So anyway, let me say what we're doing now, and I'm actually gonna call it a night. If you didn't see the stuff in Discord, I don't really want to talk about it on stream, but some personal stuff happened this weekend, so yeah. So on Friday, I believe, this book came in, Book of Monads. Let me go. Let's look inside of it. Let's see if we can find the type setting, because it's gorgeous. Oh, it looks terrible in this. Ah, that's awful. I see what I think it was Newmaid was saying. The book in this looks terrible. It's absolutely beautiful in print. This is very bad. Yeah, I didn't look at this before. I just looked at the table of contents and moved on. Anyway, yeah, so this is the book we're gonna work on, and on Friday I got the print version, and I sent an email to Alejandro. I think it's Serrano Mena. I'm not sure how to pronounce it correctly. And he basically just said, yeah, go ahead, do what you go ahead and stream everything. So I was like super pumped. So we're gonna do it. And the cool thing about this book specifically is, well, it's a little bit expensive. It's more expensive. Well, is it more expensive than the Haskell book? I don't think so. I forget how much this book is. Yeah, it's a little bit cheaper than this book, but it's all about monads and practically using monads. So I'm pretty excited about that. So right now we're working through chapter 1, but we didn't finish. Oh, the book is beautiful. I think just the typesetting is almost worth owning this book, but I'm kind of a textbook nerd, so as you probably know. Yeah, and I think that this book specifically is designed to give us a practical understanding of monads, whereas in Haskell programming from first principles, it was very abstract. So I think what we're going to try and do is we're going to try and work on Book of Monads and thinking with types at the same time. And we're also going to be doing those katas and possibly the project all at the same time. So we're going to try and mix all of this stuff together. I was just really excited about this book, so I wanted to start it as soon as possible. And Alejandro said it was fine. I still need to get clarification on if I can share the code online or not, like just through GitHub, but he was very nice about it. Book of Mormon. I'm not going to click that because I don't exactly know where it's going to take me. It looks like a Google image search of the Book of Mormon. Follow that link at your own demise, I suppose. I mean, it's clearly a Google search, so it should be fine, in theory. So anyway, I'm gonna call it a night for the night. I apologize for like the crazy, like normally we don't do this short of a stream, but there was some personal stuff that happened literally last night, and I didn't get enough of sleep, so I'm very tired. So thanks again for everyone for watching. New made for the bits, nice guy.